Hey everyone, here on the Free Code Camp channel, looking to get some tips on how to make award-winning JavaScript games. My name is Anya Kuba and I'm a software developer and course creator on YouTube, as well as judge for the 2021 JS13kGames competition. For those of you who have not come across the JS13kGames competition, it is a JavaScript coding competition for HTML5 game developers running yearly since 2012. Each year a theme is given. In 2021 it was space, and the fun lies in the fact that the total file size limit of your game submissions has to be under 13 KB, as per the name. And just what can you make with 13 KB of JavaScript? Well, just have a look at some of these awesome games. In this video, we will be looking at the top 20 winners from the JS13kGame competition, as well as hearing from the game creators themselves, who will talk you through the game and provide you with some of the game source code so that you can have a look for yourself what it takes to make each game. This video is great for those new to JavaScript game development and those wanting to get in on the next year's competition. So I hope you enjoy it. Now let's get to it. So the rules are simple. All your code and game assets should be smaller than or equal to 13 kilobytes, or to be exact, 13,312 bytes when zipped. Your zip package should contain an indexed HTML file in the top level folder structure, and when unzipped should work in the browser. Next, you can't use any libraries, images, or data files hosted on server or services that provide any type of data. So for example, Google fonts are not permitted. Analytics and other stat collecting scripts are also not allowed. All the game assets should fit in the package size limit. However, the A-Frame, Babylon.js, and Three.js frameworks are not counted towards that limit, but you can use them only in the WebXR category. And finally, stick to the theme. This is very much recommended, but also free to interpretation. There are some pretty creative implementations of the theme of space in this year's competition, which I can't wait to share with you. Okay, great. Now that we have the rules covered, let's hear from the competition creator, Andrzej Mazur.
Hello there, my name is Andrzej Mazur and I'm the creator of the JS13kGames competition. If you don't know, it's a JavaScript coding competition for HTML5 game developers where you have a whole month to create a game within the 13 kilobytes zip limit. It runs yearly, every August since 2012. So recently we had our 10th edition already. We're receiving an incredible amount of really awesome games submitted over the years. Many developers publish making of blog posts, and every single game have its source code published on GitHub. So there's plenty of opportunities to learn from the best. And the top 20 winners from this edition will be presented by developers themselves in this very video, so make sure to check it out.
Okay, so let's do it. Let's start from the game winner number 20 and work our way up to reveal the number one winner of the JS13kGames 2021 competition. In spot number 20, we have Hit the Space by Kimbatt. If you want to learn how to make a game with movements as smooth as butter, Hit the Space is definitely worth a look. In this game, you hold spacebar to accelerate your ship, reaching checkpoints to advance while avoiding hitting planets and going near black holes. What is also great about this game is that you can see the remaining fuel in the top left corner at all times, as without any fuel, you cannot accelerate any further. The only thing that will replenish your fuel are the different checkpoints you need to hit. If we have a look at the code, we can see how well structured the game is. Everything from the graphics to the audio has been organized in such a way that is readable to anyone wanting to have a look. Now, for those of you who have not had a go at playing around with WebGL, WebGL enables web content to use an API based on OpenGL ES 2.0 to perform 2D and 3D rendering in an HTML canvas in browsers that support it without the use of plugins. WebGL programs consist of control code written in JavaScript and shader code, or GLSL, that is executed on a computer's graphic processing unit. You can see it being instantiated here and its methods being used throughout the project. To be exact, this is WebGL 2, and if you want to learn more about it and its fundamentals, please go here. If you use the JavaScript library 3JS, this kind of code might look familiar to you. That is because libraries or frameworks such as 3JS and Babylon.js encapsulate WebGL's capabilities, making it easier to build 3D applications and games. Of this game, Judge Bjorn Ritzel said, "Catchy music. I like the slingshot gravity and it feels just about right in terms of difficulty. I wonder how the game would play if it was possible to zoom out and see the target planet before launching." And I said that it was deceptively harder than it looks. Maybe I'm just bad at the game though. If you want to have a go yourself, please check out the link for the game and its source code in the description below. At number 19, we have Galaxy Raid by Josep del Rio. What was great about this game was the fact that there were levels to be unlocked. Pretty impressive for a game that is only 13 KB in size. In this game, you fight your way through 6 different missions, collect fragments, and upgrade your ship. On desktop, the ship itself will follow your cursor and a bomb will be launched on the click of a button. The game also has a touch option in which you can choose to move the ship with your finger and tap with a second finger to launch a bomb. Don't want to use either of those? Perhaps you want to use the keyboard option. Use the arrows or WASD on your keyboard to move and the spacebar or enter to launch a bomb. And even more impressively, there is also a gamepad option which supports both analog sticks and directional pads. Use A, B, X or Y to launch a bomb with this method. This game really covered a lot for 13 KB and also managed to make the web monetization part of the competition by allowing Coil members to customize their ship color, claim 1,000 fragments, and unlock all missions. I also enjoyed all the cutscenes. If we want to cheat, we can have a quick look at the game code to have a read of all the text for those scenes. Clearly, a lot of thought has gone into this game, and I can't help but be super impressed. And what did the experts have to say? Nathan Lai called this a nostalgic send-up of games like Galaga. This game offers a healthy amount of challenges and satisfying progression with the upgrade system. All it really needs is some music to make the action a little punchier, but overall the game is great. The web monetization features are excellent given the amount of challenge present in this game. Normally, I don't like being able to simply bypass gameplay, but in this case, this allows less skilled players to experience the entire game in some form. And Eva Mazur said, "Everything is well marked. Both subscribers and non-subscribers can read right away what a bonus is. You can clearly see when options are available and when they are not. It's nice that there are several bonuses. The subscriber can decide for himself which to choose. Bravo, the perfect implementation of web monetization." At spot number 18, we have the game Escape by the duo who go by the name of Piesku.
Yes.
Oh, hi, we didn't see you there. Just having fun with my dog. This is Michał.
And this is Stash.
And we're actually just playing our...
Trying to play
our game on Xbox here. The game is called Escape, and it's our submission to this year's js13kgames.com competition. Yep. All right, let's talk about Escape. What is Escape, Michał?
Escape is a short story-driven platformer with puzzles.
What kind of puzzles? So like
environmental puzzles. Like
what does that mean? Like
you push stuff, you pull stuff, you jump over stuff, jump into, etc. So it's basically walking, jumping, pushing, and pulling.
The world that Escape is set in happens in near future, where it's clear that mankind has destroyed Earth, and the only way to live is to escape.
It's basically too late for anything else. So we know we screwed up and we need to find a new home.
Right, but the game is not about finding the new home. It's not about destination, not about humans that escape. It's about whatever we as mankind leave behind. It's about the nature, it's about wildlife. And in fact, you play as a wild animal, right?
Yeah, you play as a fox that tries to make it to the ark. Can we call it an ark?
Yeah, I think it's an arc, yeah, like a last rocket that's supposed to leave Earth.
And you're not the only one escaping, because like all the animals are escaping. Everyone wants to survive.
Right. So we try to create this sense of urgency and danger. Actually, to be honest, like since this is all finished now, I think we can be frank. Like I'm not entirely sure we succeeded at conveying this sense of urgency. Like you can see other animals escape in the background, but I feel like we also wanted to make this pretty relaxed game, chill gameplay. So like there is no rush really. It's like Witcher 3.
Where there is no mechanic of rush, the logic of rush in the game, but the environments kind of, you know, is kind of forcing you to proceed faster and faster, because there's fire everywhere around you.
Right. So there are hints. There are hints that the world is burning. You better hurry up.
Exactly.
Yeah.
And you have your cubs.
Cubs, yeah, like
that
pups,
just
yeah.
escape in random directions at the very beginning of the game, before you even gain control over the main player. So.
Right. So you start out and like the world is burning. You better find the last rocket leaving Earth soon, and on top of this, your fox babies escaped, and you have to rescue them.
Maybe we can focus more on the technicalities now.
Yeah, of course. So let's jump into it. I think one thing that I would really like to talk about is good luck. Is the framework that we use to build this game. In fact, Good Luck is a project by Michal and myself that we started 2 years ago, and it's the idea is that we wanted to create this template or like a set of good defaults that we can use for our games, mostly for our competition games, but not only. And what I think stands out is that this is not your typical library. You're not supposed to install it and then import from it.
In a way, like every game is its own engine. At the end, like.
And then but at the same time, no game has the engine.
Right. Instead of including Good Luck, like you would include your typical game engine into your project, you just clone the repository or like use a template ability of GitHub, and you use our bootstrapping utility to create a new project out of one of the examples.
And you get a lot of codes already for free there. So if you're interested in 3D physics or rendering, of course, but also some utility systems like moving around or touch input, like it's all there and it's all ready to be used. Well, maybe we should talk a little bit more what you get as part of Good Luck. And to talk about it, I think it's a good idea to talk about ECS, right?
Right.
So every entity has different behaviors attributed to it, right? But what's interesting about the ECS architecture is that the data for behaviors lives completely separate from the logic of the behavior, right? And so there's a difference between components and systems. And what I like about this architecture is that it allows you to compose different behaviors together to build something smarter, right?
Something unexpected.
Yeah. Maybe we can show an example of this. I think what's interesting is that, for example, in this blueprint, or in this object, essentially. Blueprint is just a name that we chose for functions that create objects. The movement functionality is given by the move component. And in fact, there are other objects in the game that also can move, and the only thing we needed to do is add this very same component to them, and then it just works, right? So here Michał is showing the blueprint for a bird, which is just like a decoration in the background, but it does move and it flies away into the distance, and you can see that it also has the move component, by virtue of which it does the moving. Then, like, the move component, the only thing it defines is how to move and how fast to move once some other logic decides that the entity should move. So, for example, we have this other component called control always, which is just a super simple, if you think about it, a super simple version of AI, which all it does is moves or it tells the move system that this entity should move forward every frame of the game.
Forward. Move in the direction defined by...
Right.
It's forward in this example.
In this case, it's forward. Yeah.
Right.
And you can see, like, we used lifespan here as well, which means that, you know, after 10 seconds, the bird, you know, has probably flown into the distance, into the fog, so you can't see it anymore. And so we just destroy the object, and it's no more. So you can think of this like you compose the behavior for an entity out of many different components, and then you have a number of systems that all work on different combinations of these components. So this one is actually very simple. It only works on the lifespan component, but maybe if you show a different one.
And shake maybe.
So, yeah, this one.
Yeah, so shake expects the entity to have a transform and the shake components.
Right. So actually every entity in the entire game, as long as it has these two components, will go through this system. And this is very powerful. Like you can move different things randomly. That's what the shake system does. Depending on where you need it and how you need it. So, for example, when we implemented the fire, that's a particle emitter that just moves very quickly every frame randomly and produces this erratic effect. It looks like the fire is burning in a wide volume of space. All of this is just implemented using a simple for loop, and it's. I think that I loved it, and I still love that Good Luck is so simple. Like that's the entire logic of the game. Really, is that you have a couple of functions, like a number of functions, and all they do is just pretty stupidly iterate over everything in the world and see, do I need to check this? No. Do I need to check this? Do I need to check this? And you can do this thousands of times per frame, and it's crazy how performant modern browsers and modern computers are. Like, I think when we profile this, like the entire update part of the game takes 2 or 3 milliseconds. It's nuts.
Right. So this is where every system is being called, and every single one of those iterate over every entity inside the game.
Yeah, and I think last I counted, we had like 4,000 entities in the game. So like this is doing probably 20 or 25 iterations over all 4,000 of entities, and again, it takes almost no time at all, which maybe is a little bit counterintuitive. You know, like I just loved it when we first discovered that the good old for loop is actually the most performant way of doing that. Let's jump into to how we build the world of Escape.
Right. So we used Blender to build our props, and this is a barn from the farm level. Every prop is built from 2 primitives, I believe. So we use a cube. Mm-hmm. Most of parts of this barn is cube, and we used cylinder. No.
Cylinder, yeah.
Cylinder, yeah. So as you can see here, those are just bunch of cubes with a cylinder inside.
So actually, like a single barn is, what is it, like 15 different entities, each one rendering a cube or a cylinder, and they're all put together, in the right place on the right angle to give the final result of the barn. And
right, and we did the same for maps. So every element here in the map is has a name of a prop. Like we have a bush property, we have a box property, barn that I showed you earlier, and
they're just cubes here in this file, right? But
they're just cubes or cylinders here because of the I don't know why. It was easier.
Simple, I guess.
And when we export the file like that. It's a city. Okay, yeah. It's the logic here is the same as it was in exporting props. Like every no, this is ground, but it's, okay. So for instance, we have a fence instance that's located in some place of the world, and it's rotated and scaled according to how it is in Blender, how we set it up in Blender. Right.
All right. Yeah, I think that's all I wanted to say about Escape. But be sure to play it if you thought this was interesting. And whenever you feel like learning about game dev or making your own game, give Good Luck a try.
Yeah, consider it as your next js13k tool of choice.
All right, thanks.
Yeah, thanks.
At spot 17, we have the game Gamut Shift by One Grumpy Dude. The first thing that is hard to miss about this game is the cool transitions and wonderful 3D graphics. Once again, thanks to WebGL2. This game asks you to push stuff around to essentially unlock passageways and reach exit portals. We use the WASD keys or arrow keys to move around and the spacebar to undo last push actions, as well as R to restart the current level. Levels are made by creating arrays of symbols or text that symbolize a game piece, similar to the approach on newer game libraries such as Kaboom.js. You can view some of the levels in this level.js file. I like this approach as it makes it easy for us as game developers to visualize what we are working with. Judge Krista Kaitila said, "Phenomenal. When I saw loud audio head warning, I knew already this game was going to be polished and thoughtful. Thank you for that." Then, once the amazing music faded in and the spectacular transition shader showed me the world, full of awesome detailed graphics, my jaw hit the floor. Wicked work. The shines, the shadows, the reflections, the warp lens effects on completing a level, beautiful. The gameplay? Well, it's a nice soccer band game, very familiar, but the puzzles were great and difficulty progression was comfy and welcome. Amazing work. At spot 16, we have Adventure in ASC2 Space by Nicklas Löf.
Hello, my name is Nicklas, and I have a confession to make. I'm a game dev addict. For js13k this year, I submitted 3 entries. And they all ended up in top 50. In this video, I want to talk about 2 of these games. So the first game I want to talk about is Adventure in ASCII Space, which was my main entry this year. As a kid, I played games like I.O., Armalite on my Commodore 64, where you travel through space with your ship and shooting down enemies, watching out for bullets. And I wanted to make that kind of game this year. So I was very happy when I saw that space was actually the theme. So here's the intro text. Most people skip this. If you didn't skip it, you got some instructions and you also get an achievement in OS 13K. So here is my ship traveling through ASCII space, shooting down enemies, collecting resources. And with these resources I have an upgrade panel, so I can it's an upgrade tree. So you need to pick things in the right order, or select which one you want to have first, which tree to select. And this will increase the laser speed, for example. But then it became quite boring. I mean, just these random formations. So I started to add in levels. So I just going to pick one more upgrade here. As you can see here, levels. Then you couldn't lose. And then I added in checkpoints. And this was a bit problematic, because I could have automatic checkpoints, but then you might lose some of these materials, like I did here. The problem was that some people that didn't read the instructions thought that that C that came towards me was actually an enemy and avoided them. So yeah, I'm not going to show the whole level, but this is the start of the level. As you could see, the game is ASCII based, so I didn't draw any graphic at all. I had that issue last year. The texture got a bit too big, took up too much space, and I had to remove gameplay from the game. So I was thinking, oh, maybe I will just do an ASCII graphic. And ASCII is built into web browsers because that's just a font. So you can see here that I'm actually just creating an canvas where I'm filling with text. So this is the character, this is actually the ship. I have a few character here that I'm using later on as sprites. This is actually the heart. There is an ASCII code for that, so you can get a heart for displaying the health. Also, I'm using some tricks for generating fake light, and for that I need a circle. So I'm actually adding a circle here as well that I'm using later to create fake light. One issue I had with this technique was that the font is a little bit different in different web browsers. I mean, that's okay. They look a bit different. But actually the positions differs a little bit as well. And not even in web browsers on the same operating system. Actually, it did differ on different Windows 10 versions. So I had to add a little bit of padding around each character, which ended up as a sprite in the end. But in the end, I think it worked. I tested on a bunch of different operating systems and browsers, and I didn't see anyone complain about it. Everything is WebGL. I'm using this tiny sprite module that I found on the js13k resource page. So I didn't have to do the WebGL stuff myself this time. So why do I need WebGL? Well, as you can see, there's a lot of things going on. Particles and bullets. And doing that without WebGL would have caused the game to be very, very, very low FPS. One last thing I want to show before moving on to next game is the level. So to generate a level, I actually draw it here in GIMP. And this is actually the level as a PNG file, where you can see the level structure, the different entities, and also decorations. Everything has different colors. In the end, the PNG file is a bit too big, actually. So I needed a way to compress it even further. And I wrote a level compiler. This is actually something I did for my game last year, so I've been reusing my own code. So I'm going through the image data and looking at the RGB colors. And when they match, I'm adding a character to a text file. And then I do that for every color in the PNG file. And that will end up as a text file like this. And this is much better. This can be compressed a lot. And then in the game I'm reading this text file and picking the level character here. I'm adding tiles or adding formations or whatever I want. So that's a very silly way to make a level. And then I was basically done with the game and I had almost 3 weeks left. So I started to play around with another game called Running Out of Space. I didn't mean to submit it, but in the end it became a quite okay game. But it's actually not the one I'm going to talk about now. It's this one, Space Block Invaders. And I didn't mean to make a game of it, actually, in the beginning. I just wanted to see how much of a Minecraft clone could be done in 13 kilobytes. So what you see here is basically the first day. I was having blocks added and created, and I had noise functions to create a very simple landscape. I didn't have any collisions at all here, so I'm just flying around in a very limited area. Then I was working on the code a bit more. I was adding collisions and I thought that will be very difficult. But in the end it turned out fairly easy to do, and I had the collisions done in like 30 minutes or so using AAB collisions. So here we can see that I can walk around. I can actually place blocks and remove blocks. And the following day I added trees. Minecraft has a lot of trees, so I was adding in trees as well. And as you can see, there is some very basic shadows under the trees. So that's a kind of emulated sunlight. Then I worked almost 2 days on implementing ambient occlusion. So as you can see here, the shadows under the trees is much more smooth now. I had a bunch of issues getting this technique right. And there's actually some bugs still in it, but it's not very visible. So this gives the very smooth shadows. This was just 3 days before the deadline, and I actually got a whole day on my own, which I didn't plan, and I couldn't resist. I added some very simple gameplay to this world. So I made the Space Invader character, and you have to run around and shoot them before they destroy the world. It's actually not really fun gameplay. There's no goal of the game. But this was what I had time to add in 1 day. So what did I do to make the game run fast in a web browser? Well, first of all, I'm using WebGL. This would have been impossible to do without WebGL. Actually reusing code again from my entry last year, where I had some basic mesh generation. So this is normal WebGL stuff. I have a mesh builder, so I don't have to fiddle with vertices in other classes. So I can just say add a left side, add a right side to the mesh. with the right UV values, colors, and other light values. And yeah, I think that's all the properties. So the world is basically an empty shell. You only want to render what's visible to the player. So if you have two blocks on top of each other, we don't want to render the top of the bottom block. We don't want to render the bottom of the upper block, if that makes sense, because that would never be visible. So when I'm building the mesh, I'm actually checking here if the block at the top, if that's not existing, yeah, then add the top side. And then we do that for all the sides of the block. And that makes a huge difference. If we didn't have this code, the game would be very, very, very slow. And this is the texture atlas I'm using. So this is all the textures in the game. But because it's repeating all over in a 3D world, it looks like much more. And I'm also tinting and using different tricks to reuse the same texture in various ways. After the competition, I continued to work on this for about a week, adding in basically endless terrain, so it's rendering until the web browser runs out of memory. I added basic crafting and a UI for that, and different type of tools. I also added a sheep that walks around, a very stupid AI, but yeah, gives a bit life to the world. I added water, but that's just an illusion. It looks like water, but when you can go through it, but you can't swim. Then I started adding in caves, and I didn't get the result I wanted from the caves, and somewhere around that point I actually stop working on this. But I might reuse the engine or parts of the engine next year for js13k. Who knows? So, that's all I have to show. Well, I could actually talk about this for hours, but I have to keep this short. The music you have heard in the background is my own. There's links here showing my 2 albums on Spotify. I have a blog that's very inactive. I have Twitter. Just ping me there if you want to talk about something. And see you next year in js13k.
At place 15, we have Q1K3 by Phoboslab.
Hi, my name is Dominic and this is my js13k entry for 2021. I'm not really sure how to pronounce it, so let's just call it Quick. This game was done as a tribute to the original Quake from 1996, and it doesn't really match the competition's theme, but I really wanted to do this, so here we are. Quick features 2 levels, 5 types of enemies, 3 different weapons, 30 different textures, a robust collision detection, not so smart but not completely dumb AI, some nice ambient music, and spatial audio. I want to go into some more detail about how all the data fits into the game, how the textures, levels, and models are stored. Let's start with the levels. I had some experience with building levels, or maps as we called them, for Quake 3. Since I was aiming to reproduce parts of Quake 1, I thought using a map editor for Quake would be a good fit. Back in the day we used a tool called Radiant, and while it wasn't really bad, in hindsight it feels a bit clunky. So this is Trenchbroom. It's a map editor for various Quake engine games made by Christian Duske, and I can't say enough nice words about it. It's really good. It's completely free and open source, so go check it out. While Quake maps allow for all kinds of funky geometry, I limited myself to only use axis-aligned blocks. These blocks can be quite small to allow for stair steps or some details in the maps, but they can also be huge. One block can cover the floor or the ceiling of multiple rooms. I was able to capture most of the famous E1M1 map from Quake 1, the Slipgate complex, with just about 200 of these blocks. I have to admit though that the original map comes with a lot of secret passages and rooms that I wasn't able to fit in. So these 200 blocks can be stored in a binary file with just 7 bytes each, 1 byte for the x, y, and z coordinates of the block, and 1 byte for the width, length, and height, and another byte for the texture index. These binary files with all the blocks are loaded in JavaScript into a big array buffer, and all the vertices for WebGL are constructed from it. The entities, so all the things that are in the map, the light sources, the enemies, ammo and health boxes, and so on, are stored with 1 byte each for the type ID, 3 bytes for the position, and 2 extra bytes for some extra attributes. For instance, for the light sources, one of these extra bytes is used for the brightness, and one is used for the color value. So with all this, in the end I managed to squeeze in 2 maps using up a whopping 3.2 kilobytes in the zip file. The models for the game again are stored in the simplest way possible. It's just a set of 3 byte coordinates defining the vertices, and then a list of indices where each 3 indices define one triangle or face of the model. For the animated models, the list of vertices is just repeated for each animation frame. I was able to get away with very few animation frames by just linearly interpolating between them. I was using Wings 3D to create those models. I exported them as a wavefront object file and converted them into a binary file with a PHP script. It's not really a good workflow, and I really should learn a bit of Blender. Next up, textures. This was probably the best idea I had for this game. Instead of creating the textures as PNG files and just saving them in the zip, the textures are created on the fly as canvas elements when you first load up the game. This idea is nothing new. The demo scene has done it since forever, but I falsely assumed that you needed some complex operations to achieve good results with generated textures. Nevertheless, I tinkered a bit with the idea, and after some promising first results with drawing random stuff on canvas elements, I built a really simple editor to create those textures. And I mean really, really simple. This editor just supports 5 different operations. You can draw a rectangle, you can draw a grid of rectangles, you can draw some random noise, draw text, or draw a previous texture. In the end, I was quite surprised myself with the results you can get with this. It was really unexpected. Also, it turned out to be a lot of fun to build those textures. The result of all this is a JSON array that defines those textures, all 30 of them, and a tiny library that reads this array and spits out canvas elements. The whole thing is on GitHub. It's called Tiny Texture Tumblr if you want to check it out. I won't go into detail of how the music is stored, but the short version is that it's similar to the textures. It's just a JSON array of nodes that gets rendered into an audio buffer. So with all the data out of the way, I had about 5.9 kilobytes left for the code. I want to show just 2 things in the code in particular, and one of those things is the renderer. I'm using WebGL to draw everything onto the screen, and everything in the game world is spit out to the GPU for each frame. There's no occlusion culling or fancy math to figure out the visibility, and it doesn't really matter, computers are fast. The renderer uses only one shader program for everything, so all the enemies and the whole game world are drawn with the same shader. The vertex shader handles the view rotation, the direction you look at, the view position, the object's rotation, and blending between 2 animation frames for an object. Of course, it's inefficient to draw the static world geometry of a shader that can blend animation frames and rotate geometry, but again, it doesn't really matter. Computers are fast. The fragment shader applies a uniform array of light coordinates and light colors to every pixel and does little else. It does this in a loop, one iteration for each light source. So the number of lights in the game is fixed to 32. And to stay within this limit, the lights are faded out after a certain distance. You can see this fade out in a few parts of the game, but honestly, I think it looks cool and it adds to the atmosphere. It's a feature, not a bug. Completely unrelated to rendering, here's the collision detection routine that is executed for each entity, for each frame. This is very similar to what I was doing in my previous game, Underrun, but this time I'm doing it in 3 dimensions instead of 2. But the idea is the same. First, you remember the current known good position of an entity. You advance this position according to the entity's velocity, and you test if the final x position of this entity with the old y and old z position collides. If yes, you roll back the final x position to the old position. And then you do the same thing for the y and z coordinates. Checking each of the 3 axes individually instead of just doing one test with the final position allows you to slide along the floor and walls, and it turned out to be really robust. The real code that is used in the game does a bit more stuff. In particular, it checks if we can step up a staircase or if an entity needs to bounce off from the ground. This is used for the bouncy grenades, for instance. But the gist is the same. It's just a bunch of simple checks, no complex math stuff going on. There's one last thing I want to get into, and that's keyboard input. If you do WASD movement in your game, I urge you to use the keyboard event's code property. This property is keyboard layout agnostic, which means WASD works on French keyboards and Z and Y keys are not switched on German keyboards. The code property basically reports the key based on the US keyboard layout, so you're defining your keys by the position on the keyboard, no matter what layout is actually used in the end. So the user's local keyboard layout is completely ignored, which is exactly what you want for your games. That's about it. If you're interested in some more detail about the game, I wrote a making of post on my blog, Phoboslab.org. Thanks for watching and see you next year.
At Spot 14, we had the game Celestial Lighthouse by Tom Hermans.
Hi, I'm Tom. For js13k last year I made a game called Edge Not Found. This year I made Celestial Lighthouse, which is a physics puzzle game about placing blocks in the atmosphere of planets without letting them fall into the planet's core. So to achieve this circular gravity, I adapted the physics library Mattia and their attractor plugin. So today I'd like to demonstrate the level format. Since Edge Not Found was a grid-based game, the level format was quite straightforward there. Celestial Lighthouse also required it, since generating all of the physics shapes manually would require lots of code. And with js13k, you should usually try to pack your data in as little space as possible, preferably building in hard assumptions that reduce file size where possible. This is why, for example, I chose to set this data up as an array instead of an object with more readable property names. So in Celestial Lighthouse, each level has a lava core and an atmosphere. So since this is a constant and a level define, we just define its size here. And the level generation code just takes care of building the actual shapes based on the input. Furthermore, we define which shapes can appear at random to be placed by the player. So simple shapes as defined here can be a square, rectangle or trapezium. This is then used by the game as a grab bag of sorts to randomly select the blocks to place. Once you place a certain number of blocks, 12 in this case, you win the level. Finally, levels have solid platforms. Those are these black shapes in the level. These can only be regular polygons, like like triangles, squares, and even circles. You can also cut the shape in half by making them negative. And if you require, you can also change the size, the starting angle, the scale, and you can even set a rotation speed. And yeah, that's pretty much it. I really enjoyed this level format because it makes iterating on the level design a breeze. So my main takeaway here is to make it as easy as possible for yourself to test and improve your game and the levels in it. Right, bye and thanks for watching.
At number 13, we have Space Jam by Mark Racette.
Hey folks, I'm Mark Racette. I'm a developer and musician currently based in Austin, Texas, and today I'm going to be talking a bit about my JS13k entry called Space Jam. I actually got the idea for Space Jam from playing farming games like Stardew Valley. I began to wonder if it was possible to make a game where you build up a settlement using musical instruments as the building blocks for the game. In Space Jam, the gameplay is pretty simple. You start off with 2 instruments and this oscillator. Basically, the way it works is you can add new instruments to the board using the notes that you collect when the oscillator strikes an instrument. In this way, you can build up patterns and beats and ultimately earn more notes to unlock more instruments. You can build additional oscillators to kind of expand your beat repertoire and place them in different areas of the map. So next up, I thought I would talk about the spatial audio in Space Jam. Basically, the way this works at a high level is you have this map and you've got a grid and the camera is kind of centered in the middle of the map and there's instruments that you can place and they're going to be some distance from the camera, and that's kind of where your center is as the player. And so as these move, from left to right or up and down, I wanted to make sure that I was taking into account their position relative to this point and controlling the audio effects accordingly. So the first thing that's going to happen is they're going to pan left or right. So this is going to pan slightly to the right, this is going to pan a little bit more to the left, and if an instrument is all the way at the bounds of your viewport, it's going to be panning fully in that direction. So panning is the first thing to come into play, and then the second thing is just going to be based on the absolute distance from the center. That's going to affect the amount of reverb that's applied to that sound and also just the overall volume of that sound. So what that looks like in code, I've basically consolidated all of this to this function. And update spatial effects is something that happens up here in this move camera function. So yeah, basically anytime the camera moves relative to the instruments, you need to update their effects. And so this has got a bunch of other stuff going on, but again, we're just going to hone in on this function here. So this actually takes the instrument that was affected by this camera move, and then first it calculates the pan values. So pan x is going to be the instrument's position in the x direction and the delta of that with the camera's position in the x direction. So again, just these types of values right here. That's in relation to the viewport itself, and you clamp this here. I just have like a utility function that clamps. If you don't know about that, look into it. It's super useful for just any type of kind of quantitative coding, but especially creative stuff like games. So basically what this is saying is the pan x is never going to be less than -1 or greater than 1. Same exact thing with the pan y, just in the y direction. The radius, this is just a simple calculation, Pythagorean theorem right here. And again, the radius is important because it controls the volume.
In at number 12, we have First Contact by Mark Vasilkov.
Hey people, Mark Vasilkov here. I'm a security enthusiast from Israel. It's M Vasilkov on GitHub and Twitter and Gmail, what have you, and I'm working for this magnificent little company called No Name Security. We do defensive cybersecurity for protecting APIs. The game I want to talk about today, First Contact, was written for the JS13 compo in 2021. It's a simple clicker game, and I have footage of it here. So yeah, the usual staples of the genre are all present. It's instant gratification based, the game practically plays itself, it's not skill based. What I attempted to do with this formula was add a little story. Some of the things just happen and you have no control over them. There are two different endings based on the subtle player choice, this sort of thing. Now for the source code, the thing I'm sufficiently happy with is how it's coded to the browser's JavaScript engine. The idea was to avoid problems like performance problems during the high-level design so that we don't need super clever optimizations later, like 2 days before release. I'll give two small examples of that. First, in JavaScript, garbage collector can unpredictably pause the execution of your program and do its thing to free memory. And on a 60 FPS monitor, you have 16.5 milliseconds to render each frame, meaning that garbage collector can drop frames easily and make the game stutter. And one workaround for that is to just allocate everything you need ahead of time so that garbage collector has nothing to do. For example, in the First Contact game, there are all these objects. There are orbital platforms and cannons and projectiles and of course the invaders. And every object is a very small state machine with a small number of states. So let me show it here. In the source code, a cannon can be either ready to fire or it can be reloading. What helps with garbage collector is that all objects have an additional state which is called missing, which you can see right here. And so when we fire a rocket, we do not allocate a new object like new rocket. We instead pre-allocate all of the rockets at the start of the game, set them to missing by default, and when we need it to fire, we find the first one that's missing and use that. When the rocket hits, it reverts back to the missing state. So we have 0 allocations and garbage collector is very happy with us. So here you can see, for example, like the cannon, which has all these states, and when we, at the start of the application, when we create all of the possible like cannons and rockets and invaders, we just allocate them here. There is no allocation, there is no like new cannon or new rocket anywhere in the code apart from this specific place at the beginning of the game. Yeah, the second thing is also very small and it's related to the fact that all drawing in this game is done on HTML canvas. And canvas has great performance, but when you need to render possibly thousands of objects in every frame at 60 frames per second or more, the rendering costs quickly add up. The trick is very simple. Let's say we have these space invaders. Drawing one invader is simple. We make a bunch of line to calls and then we call stroke or fill or what have you. You're all familiar with the Canvas API. Now, what about drawing 1,000 of these? It turns out one way to optimize mass rendering is to first make all of the line to calls for all the invaders. Like here, you can see the render method for the invader. And it has all these line twos and close path. And when we actually invoke this method here, we have a function to render all of the invaders at once. So it first invokes all the line twos and only then it does a stroke or fill or anything. This works because the browser's Canvas implementation, which is actually a high-performance C++ code, works best if we give it a lot of stuff to rasterize at once, so like all of the invaders or all of the particles at once. The anti-pattern here would be calling stroke like every time for each line segment, and this is known to kill performance. So that's all from me. Come participate in JS13K competition next year.
In at number 11, we have Shuttle Deck by Ariel Wexler.
Hi, my name is Ariel, and I'm the creator of Shuttle Deck. You can find me on Twitter as Ari Neon Shark. I make all sorts of games, simulations, and fun little procedural animations. Okay, so let's dive right in and take a look at Shuttle Deck. At its core, Shuttle Deck is an infinite runner crossed with a deck builder game. So I thought that would just be a funny combination of genres. I haven't seen that done before. So here we are in Professor Zorn's lab, and we're serving kind of as a space courier. We'll be traveling between planets, avoiding obstacles on the way, and we need to help Professor Zorn over here on the right to deliver his package, the Xenotransponder. So let's go ahead and help him out. So here we are traveling through space. We see some minerals, we see some asteroids, and I have these cards down here. I can press on these cards and it will actually change the lane that my spaceship is in. That was a pretty easy run for me. I didn't have any obstacles that really were in my way. Excellent. In between levels, so I just moved between two planets there. Every time I reach a new planet, I'll encounter some sort of strange character, in this case the street merchant, and he's offering me a few cards that I can buy. Now in this case I don't actually have enough minerals to buy the cards that he's offering, so we're gonna have to go again. Let's check out one more stop here and see if we'll actually be able to afford something. I just missed that. That's unfortunate. And here we go. Okay, it's looking pretty good. 16 usually goes a long way. Alright, the Kepler Missile, no problem. Let's go ahead and grab one of those. What this will help me do is if I have an asteroid in my way, I'll just be able to shoot it, boom, and get it out of my way. Perfect. So that's the core of the game. And now I guess we can dive into a bit of how it all works. And what I'm really excited to share with you guys is the event emitter. I have my own custom implementation of a very, very small event emitter that I used in the game. So we'll look at the code in a moment, but let's just talk quickly about why this is important in a game at all. So you just saw Shuttle Deck, and the way that it actually works is the game engine itself is completely decoupled from all of these other little components. They don't really know about each other. So let's think for a moment about, maybe how the main character shoots rockets. So the way that works is if you have the, shoot a rocket card right here, right? So we have that here. The player is going to click this, and what's going to happen is a little event is going to be emitted, and I'll kind of draw that as a little loudspeaker. So I'm holding a loudspeaker and it's shouting out. Now what's happening is all these other systems in the game, you can think of them as ears. They're essentially listening. So that's what an ear looks like, I guess. So all these systems are listening, and what they're listening for is events. In this case, the event was, hey, I pressed the shoot a rocket card. So each one of these systems is actually going to receive that message, but only the relevant one should respond. I'd like to take some time to look at the actual code that, fuels all this. So here we are in the cards definition file. This has all the cards in the game, has their color, their name, how much it costs to use them or buy them, a little code to render them, the little glyph that shows up on the card in game, and finally there is the actual code for handling what happens when you use the card. None of the actual implementation of what to do when you use the card lives in here. It actually just outsources all of that using that exact same strategy of just emitting what should happen, and all the relevant systems on the other end are kind of receiving what to do with these emits. So here we are looking at the Kepler Missile, the same thing we've been talking about throughout all the examples, and all it does is says, hey, when you use this card, just emit projectile type 1. It just says that out into the world, and the world of the game needs to then understand what to do with that. So let's go ahead and look at who might receive that. So here we are. I'm looking at the main game engine that's actually listening for projectile events, and it's listening for the projectile type as the only data parameter that comes into it. So just like the projectile creation code we just looked at, here I am in the audio manager, and we can see right here that I'm listening to that exact same event, and I receive the actual type. If the type is type 1, I play the sound for a missile. So here you can actually see all the sounds for the game. I'm just listening for all sorts of other events that are going on, and I play the correspondingly correct sound. I didn't have to introduce anything intrusive at other parts of the game. It is all nicely localized right here. So why am I bringing this up at all? Well, mostly because I love using event emitters, and I think they're a very necessary part of making certain types of games. And if we look at, state-of-the-art libraries like Event Emitter 3, let's say for JavaScript or Node, this thing is getting 15 million weekly downloads. Like, oh my goodness. So this sounds like the right thing to use, right? Yeah, well, there's only one problem with that. If we go ahead and actually look at the minified code for it, it's kind of massive, and it's a bit more feature-rich than we probably need. In fact, this is about, 3 KB. It could probably compress a bit more using a few of our tools, but still, this is way too much code for what we actually need. So we're finally getting to the punchline of what I'm so excited to share with you, and here it is. It's the really, really small version of an event emitter library that compresses really nicely. Here it says it's about 346 bytes, but actually, once this goes through a minifier and uglifier, this code will go down to close to about 112 bytes. And I guess when you run it through Road Roller, it'll probably be even less than that in the grand scheme. So thanks for tuning in and checking out Shuttle Deck. I hope you enjoyed what I had to share about it.
At number 10, we have Lost, A Snake in Space by Sam. Reading on behalf of Maxime. Hello, I'm Maxime, a web developer and game developer from France, and I developed my 10th js13k game entry this year. You can find me on Twitter here, or on YouTube, or on my blog. This year, I made a puzzle game where you control a little snake that visits different worlds and needs to reproduce the patterns drawn on the floor with his body to progress and eventually reach the moon, where he will find the final hardest puzzles of the game. In each world, you learn new mechanics like climbing walls, using teleporters, rapping, moving in 3D, and so on, and it becomes quite challenging when you pass the first puzzles. You can play it on PC and mobile, right here. In regards to the code, my favorite parts of the code is the graphics. The first is regarding the snake. I spent many days researching a way to represent a cute snake in 3D and finally found an elegant solution that requires very little code. I use a big circle for the head and many smaller circles for the body. Aligning all these circles and making them move together gives a pretty good illusion of a snake body with a real volume, even if it's just a bunch of flat circles rendered with HTML and CSS. The game is rendered with a little CSS 3D library that I developed before the competition. It is called CSS 3D Framework, and you can find it here. It allows us to easily draw and animate 3D shapes with very little code. Here is the JS code for the snake. And here is the CSS code for the snake as well. Next up, I want to talk about the code I use for the ground textures. During the competition, I met Bence. He creates gorgeous textures using SVGs. Each of them is about half a kilobyte, which is perfect for js13kGames, where the entire game size is very limited. All the textures present in my game were created by him. The grass, the sand, the moon, and even the lava. All his CSV art can be found just right here. Here are the textures I used in my game and their minified SVG code. Here we have the grass, here we have the sand, here we have the moon, and here we have the lava. These techniques and many others are detailed in the game's making of right over here. Thanks and see you next year. At number 9, we have Black Hole Square by Quinten Klaus.
Hello, my name is Quinten Klaus. This is the first time I submitted something for js13k. I've been following the competition for as long as I can remember, but this is the first year I submitted something. The game is called Black Hole Square. As you can see, it's a little bit a heavy focus on mobile controls. Actually, you just tap the tiles, they move, so you have different kinds of tiles that move in different directions, and the goal of the game is to put all the tiles into black holes, little black holes. So you need to clear the screen of all the white tiles, and then you finish a level. So when I'm not participating in the game jam, I keep a text document in which I write game ideas I have, things that come to mind. I write them all down in this text document, and then when a game jam starts, I'll quickly go over it and see if there are any ideas I can use. Actually, this year's idea was from a sketch I already scribbled down in my notebooks. So when the jam starts, I create a new document, which will be like a design document for the game, in which I put to-dos, like little notes. I don't actually do all these things, but just if I have any ideas, I just put them in there, and also put the copy in there. So the copy for the game, like little sketches for levels. The graphics are made with Affinity Designer, and then I export them as SVG, and then I use a tool called SVGO. You can install it with NPM globally, and then you can compress the SVGs, and then I take out the paths, and I use Path2D to render the different parts of the SVG. One of the most important files in the code base is the entities.json. It contains all the data from the game, like the order in which the puzzles are, the copy for the game, and the puzzles themselves. So they are just little arrays. At this point, I always have a very small notebook in my pocket, so I can make little levels when I'm on the go, when I'm waiting for something. I just make little levels. Just make them on paper first, and then afterwards I put them in here. One of the most important files where most of the code is the puzzle.js. It also contains the keys, so there's a comment which contains the keys, which all the digits are in the arrays of the levels. As you can see, it contains a lot of code. Like, mostly when I'm working, there's always one file in the code base that starts piling up code. In this project, it's the puzzle.js. It's really a mess, like no comments or anything. It also contains my favorite part of the code, which is an event listener for the wheel event, which actually makes the swiping, like the swiping controls, makes them work on a laptop. If you swipe on the trackpad, like it works on all the laptops I tried. So yeah, listening for the wheel event, you can make the swiping work on desktop too, or on laptops at least. That's it. If you want to find out more about my work, you can find me on the internet on these URLs. If you have any questions, I'd be happy to answer them. Yeah, thank you for listening, and I hope to see you on another edition of JS13K. Thank you.
In spot 8, we have Space Huggers by Frank Force.
Howdy, I'm Frank Force, also known as Killed by a Pixel, a game developer and generative artist in Austin, Texas. Today I'm going to share with you some of the secrets behind my JS13K game, Space Huggers. It's a run-and-gun roguelike hybrid with procedurally generated, fully destructible levels. It has an explosion and fire propagation system that creates all sorts of unpredictable chaos and chain reactions while you're playing. That's what I'm going to show you today. But first, let's take a look at the game and see how it works. You can get the full source code for my game Space Huggers off the GitHub website. I've already gone ahead and downloaded Space Huggers and opened it up in Visual Studio. The first thing I'm going to do is in App Effects, I'm going to enable Debug Fire. That's going to show us some debug information when a fire event occurs. For an explosion, it's going to show you two circles, an inner radius and an outer radius. The inner radius represents what is completely destroyed, and the outer radius is what's caught on fire. When something is on fire, it will draw a red circle to represent that a fire event is being sent out to nearby objects to let them know that they might also want to catch on fire. These fire events are not sent out every frame, but only periodically for optimization. Let's open up app objects and I'll show you how some of the fire stuff works. You've got a couple of variables, burn delay, that's how long it is before something starts burning, and a burn time, that's how long something burns for. Now, in the update function, it checks if it has a burn time, that means it can catch on fire. Then it checks, is the burn timer set, that means it's burning. So if the burn timer is elapsed, that means it's it's completely burnt out, which means it tries to die. If there's a fire emitter, you have to turn that off. There's also a small chance to spread the fire, and this is what causes the really cool chain reactions to happen. You don't want this to happen every frame because it's kind of a slow system to go through each and every object and check its radius to see if it's close enough to catch on fire. Of course, you can do things to speed that up, but it's always going to be a bit slow, so you don't want to do that kind of thing every single frame, and you don't need to really. It's good to have a little bit of randomness in something like this. It also checks the burn delay timer. If the burn delay timer is elapsed, then it starts burning. There's other stuff in here called a burn color percent, which just kind of alerts the burn timer to make things darker as they get burnt. And if you want to burn something directly, you would just call this burn function, and that sets up the different stuff to create the burn system. It creates a fire emitter and attaches that as a child. It sets the burn timer. And there's also a way to extinguish fires. For example, by just rolling, it will put out a fire. Or you can also be near a water barrel. When you explode a water barrel, instead of burning, it actually puts out everything nearby. And it just extinguishes things in a radius, and that sets the extinguish timer. It unsets the fire effect and timers, and sets things back to normal, basically. I hope that gives you a good idea about how the fire system in my game works and how you might implement something similar in your own game. I'm going to give you a quick demonstration to end things out here. I'd like to tell you to follow me on Twitter. I also made the game engine for this game open source. You can get that on my GitHub. It's called Little.js. Next year, I'll be using Little.js to make a new game for js13k, and I hope that you do too. So thanks for watching, take care of yourselves, and have a great day.
In 7th space, we have The Maze of Space Goblins by Jani Nykänen. The Maze of Space Goblins is a puzzle game that combines soccer band-like gameplay mechanics with match 3. The graphics are extremely retro and work very well for the type of game that it is. The level of care around the intro and the option to have the sound on or off was very much appreciated by the judges. You can play the game by collecting stars to progress to the next level and by matching 3 or more space goblins of the same color to destroy them as to make space for you to move. The game is made to use the arrow keys to move, backspace to undo a move, R to restart, and enter to pause the game. Jani tested this game on Firefox and various Chromium-based browsers such as Opera and Edge. He also tested it on Linux and Windows as to make sure the user had the best possible experience no matter what browser they were using. The bitmap font was one of my favorite fonts that I've seen in this competition. This game had also an interesting approach to creating the levels, as you can see here with the data tag, and was one of the few projects which used TypeScript to create their game, as you can see by the TSX files. Judge Jupiter Hadley said he loved the graphics, they were really simple, but a fun game. He loved the challenges in it. Ralph Mertens said the name definitely got my attention, funny intro too. The game does a good job of getting you engaged, and he thinks that the puzzles were excellent and quite challenging. They had him playing for a while. great simple puzzle game that's deceptively hard with retro visuals and sound. In 6th place we have Pack a Bunches by Mattia Fortunati.
Hi, I'm Mattia, game developer, sometimes for hobby, sometimes for work, but always for passion, because I really love games and game design. I'm very fond of js13kGames because of all the creativity it can push with all the great ideas coming out every year, and so I always try to participate whenever I can. So now let's jump to my 2021 entry, Pack a Bunches. Pack a Bunches is a colorful tiling puzzle game in which you have to rescue space creatures by packing them. It is playable from both desktop and mobile, and as for controls, you just use clicks or taps. I am really proud of this game, and not only because I think it came out to be very nice, but also, mainly, because I had a great time making it. In fact, my personal goal and approach this year was to fully enjoy the creative experience behind the development of every single part of the game. Let me explain. For example, to create the music, I didn't just sit there trying to compose something. Instead, I met with a musician friend of mine and we spent the whole afternoon listening to puzzle game music from old Nintendo games, for inspiration. We had snacks and drinks, sharing ideas in front of the piano, and in the end we came up with this bossa nova-ish, jazz-ish chord progression for Pack a Bunches. So you see, like this, whatever the result, I had a great time exploring new things with a friend. Same thing goes for the logo and the mascot, created during some brainstorms with my girlfriend, in which we had fun exaggerating shapes and trying different goofy designs, with paint for the logo and pen and paper for the little character. As for the gameplay, since the theme this year was space, I got lost for days exploring beam packing problems and space management algorithms. To get some inspiration, I eagerly explored from Feng Shui principles to scientific papers on automated furniture placement. And so I learned many things like furniture usability rankings, relationships between objects, human navigation in space, and so on. In the end, as you can see, I stuck with a more simple polyomino shaped packing game and with some heuristic brute force for level generation. But it has really been an adventure, believe me. So maybe now you're curious about Pack a Bunches code, about how it can fit in 13 kilobytes, and you want to check it on GitHub. Well, just don't do it! Pack a Bunches code is bad, messy, full of mistakes and unused, redundant, workaroundish, copy-pasty things. No, really. I couldn't make the code presentable for the deadline, so instead you should check this one. This is a basic js13kGames template which I made post-competition and which is somewhat a reorganized, cleaner version of what I use for Pack a Bunches. It includes some features that I personally see at the moment as standards in this field of making games in 13 kilobyte and that I like to reuse myself in the future. Many of these solutions are not my own, and every specific owner is credited with links. For example, here's the document setup. We have the meta tag to be sure emojis are shown, and we have the cool chip trick here to set an emoji as favicon, which will also be the game icon on mobile if you use the add to homepage feature. Then we have canvas centering and resizing, handled with viv wrapping. Very readable and very solid. As for the audio part, my tools of choice here are the ZFX and the ZFX-M by Frank Force and Keith Clark, which you may already know and which I highly suggest you to go and check out. And so, like this, we have a clickable centered fit canvas with emojis, audio, icon, and mobile compatibility. I'd say it's a great starting point to create a game. But the thing that made it really possible to fit Pack a Bunches into 13 kilobytes and that practically removed the size constraint is the build process. This year, a new JavaScript compression tool came out, making everyone's life easier. I'm talking about Roadroller by Kang Seong-gun. Go check it out. So, the suggested build process here is: first, use Google Closure Compiler to recompile the code, then Terser to crash it, and finally, Roadroller to compress it. This will extremely reduce the size of your scripts, so you can now put them inside your already minified HTML and zip them at maximum compression. And here we have one last trick up our sleeves. Using ECT, we can even optimize this final zip more, reducing its size by some extra bytes. My template also features a batch build to automate all of this, which I deliberately took from Frankfurt Sentry Space Huggers and modified for my needs. You can find it included in the build folder, all commented along with a link to the original one. Thank you, Frank. So, as you can see, even when talking about code, I've had a great time keeping up to date with the js13kGames world, discovering and playing with all these great tools. I really enjoyed making Pocket Bunches. Alright, thanks for listening, thanks to the Free Code Camp staff for the opportunity of being here, thanks to Andrzej for keeping the competition up every year, and thanks to the awesome community for sharing all the ideas, tips, and projects. Thank you guys, see ya!
In 5th place, we have Welcome to Space by Matthew Diamant. In this game, we play a hero looking to save their space station from evil but kinda cute looking aliens. These wicked aliens are armed to the teeth, but so are you. In this game, you could use your vast arsenal to conquer the 6 different alien types and make your way to the ultimate alien boss. The pixel art was adorable for this game, and the variety given to the weapons and evil alien characteristics was very impressive. I was most intrigued about the deciding jump factors that were there for the aliens, so I had a quick look at the code and must applaud how neat I found it. Here, the different types of enemy types in the game. We have the aggro enemy, the run and gun, the idiot, the pacifists, and the sentinel, each with their own color scheme for the skin, horns, eyes, and body. You will also see the different ways the enemies act, thanks to their enemy personas. To move your alien in this game, you can use the keyboard, or you can use controller support, such as a controller, D-pad, or joysticks. On the keyboard, you move with either left and right, A and D, and jump with either up or the W key, shift, or control, as well as shoot with the spacebar. Make sure to give it a go in the description below. In 4th place, we have Galaxy Rider by Jaburns. Reading on behalf of Jeremy Burns. Hi, I'm Jeremy Burns, or Jaburns, and you can find me online at jaburns.net. I built Galaxy Rider for the JS13kGames Jam in 2021. This is a game where the goals and mechanisms are simple, and the difficulty comes from learning to master the mechanics themselves. I've always liked games where progression comes from a real improvement of the player's skill, and this game sticks to the philosophy quite strongly. The goal is simply to collect all the floating dots and then get the skater to the exit as fast as possible. The initial challenge is just to complete the levels at all, and replayability comes from the timer. I was inspired to make this game because I think the physical mechanics of riding a pool or a ball on a skateboard are quite interesting and fun, and I wanted to capture some of that in a 2D platformer. I thought about doing something like this in 3D, but I just couldn't imagine pulling off a novel 3D movement mechanic in 3D in the confines of the Jam. My favourite part of the code is probably the animation editor. It's quite ugly code, but it does exactly what was required of it and nothing more, which is nice in its own kind of way. The way the animation editor works is by simply rendering some JSON-specified lines and circles to a large canvas and giving me a text field in which I can input that JSON. It also provides a timeline which I could scrub to see how animation frames could blend together, and some basic mouse handles for precision editing. I built the character sprite and all the animations using this tool. The level editor was another minimalist tool I built for the game, though it was a bit more sophisticated. It allowed me to place positive and negative shapes into the world, which when combined together formed all the various geometry you find in the game. Overall, I think the game came together quite well, and I'm happy that other people seem to enjoy it too. In third place, we have Adventures of Captain Callisto by Cody Ebberson.
Hello, my name is Cody Ebberson. I am a software engineer in San Francisco, California, and today I'd like to talk about my JS13K entry, The Adventures of Captain Callisto. Callisto is a 3D action platform game set in outer space. This is my third time entering the JS13K competition. My first entry was JS13K Battlegrounds in 2018, a battle royale first-person shooter. My second entry was Minipunk in 2020, a cyberpunk third-person action game. In those entries, my goal was to make an impressive technical demo. The entries did well graphically, but they weren't considered fun. I also noticed that a significant portion of the JS13K audience does not really enjoy first-person or third-person games. So my goals for this year were to make something fun, make something relatively easy, at least for the first few levels, and to make something with a more global appeal. The most direct inspiration for Callisto is probably Captain Toad Treasure Tracker, a Nintendo action platform game. From a technology perspective, the game rendering uses WebGL 2. I extended my previous entries to support instance rendering of cubes and spheres. That means that it's pretty fast and cheap and low code to draw a sphere or a cube on the screen. All the models are simple combinations of spheres and cubes. As an example, let's talk about the main hero character. We can strip everything away and then add the components: a visor, the rest of the helmet, the body, a jetpack, an arm, another arm, a leg, and another leg. And that's how the rendering works. We can then rotate those spheres to create the animation effects. You see these spheres all over the place. The dust clouds and the coins, they're just stretched spheres. Here's how that looks in the code. You can see how we generate the sphere, then translate it or move it, then scale it or stretch it, and then in some cases rotate it to create those animation effects. And that is the foundation of how all of the rendering works in the entire game. Okay, that was a quick tour of my entry, The Adventures of Captain Callisto. Thank you so much for watching, and thank you to the Free Code Camp team for putting this together.
In second place, we have Beat Rocks by Cos. This game allows you to unleash your inner dancer. The aim is to unlock new instruments of destruction and make sure to play them on the beat. Reading on behalf of Cos said, "I think this is my third or fourth attempt at making an asteroid game. One attempt failed because I tried too hard at making an entity component system, another because I didn't come up with any asset pipeline. So I promise that I'll try the next one in 3D with wireframe rendering so that I can have some nice animations for rotating objects while keeping the retro, it's all lines visuals. The idea was in my mind for a long time, but I wasn't eager to start until Fatfish told me that JS13 is starting and space is the theme. I couldn't pass over it. I wasn't originally planning to make this a rhythm game. The idea randomly came up later and it seemed to work. I was playing a lot of Tetris Effect earlier this year, so I tried toying with the idea of sound effects contributing to the music. Playtests reveal that it is confusing that when the player uses an ability, the effect triggers immediately, but the sound only plays on the next beat. This led to the conclusion, why not require the player to use skills on the beat? I composed the music on a Nintendo Switch, then moved it over to Soundbox. I'm interested in synths, but I have almost zero experience with composing. It's my longest song so far. Some tech facts for you about this game is that he also used Soundbox for sound effects. The sounds were done as other instruments in the same track so that he could test how everything sounds together. Since Soundbox saves the song as JSON, he was able to extract and trim the soundtracks in the game code to separate audio buffers. And in regards to the graphics, he used REGL. REGL gives a convenient typed interface over raw WebGL that deals away with all the boilerplate. Later, he rewritten the re-rendering in raw WebGL to save space. This was planned from the beginning as he knew REGL would be too big. He then modeled some 3D objects in SketchUp, saved to OBJ and converted to simple JSON representation. He also used snippets from Patricio Gonzalez Vivo's Gist for the shader noise texture, which made the backgrounds a little more interesting. In regards to the build and compression, Parcel was used for the build pipeline. He likes Parcel because it has 0 modules, TypeScript, and minification via Tersa with 0 setup. He'd never used Parcel in production, but he used it for all the toy projects and prototypes. Tersa doesn't touch shaders, so he minified them manually using GLSLX. And finally, let's reveal the #1 winner of the JS13kGames 2021. In the #1 space, we have Space Garden by Ryan Malm. Ryan says, I've always been inspired by the fantasy console community and all the fantastic things they create under tight constraints. Space Garden is the 3rd game I've made for JS13k. Space Garden is the 3rd game I've made for JS13k that uses similar constraints via a simple drawing API and frame buffer I've refined over the years that's heavily inspired by fantasy consoles. In my free time, I've been working on cleaning up retro buffer for a more official release so other jammers might more easily make a game with it. I'd love to see that. A huge thank you to Andrzej and everyone else involved with managing JS13k. It's the highlight of my year to participate. And there we have it, all 20 winners from the JS13